Hello students, let us learn Chapter 4, Structure of the Atom. In this chapter, we are going to discuss the following: Introduction, Charged particles in matter, Discovery of electron, proton and neutron, Structure of an atom, 3 proposed models of an atom: J.J. Thomson's model, Rutherford's model and Niels Bohr's model. How are electrons distributed in various shells? Valency, atomic number, mass number, isotopes and isobars. Introduction. In the previous chapter, we have studied about the Darden's atomic theory, which states that atom is the smallest particle of any substance and is further indivisible. Darden's atomic theory was able to explain the law of conservation of mass and law of constant proportion, that is, laws of chemical combination. But it could not explain the cause of some chemical reactions, like ionic reactions, in which only ions can take part or transfer of ions takes place. It also could not explain why the atoms of different elements differ from each other and why the atoms combine to form molecules. Till the end of 19th century, scientists could not explain the exact structure and important properties of an atom. Later on, the structure of atom was explained by the scientists on the basis of various experiments. Some other phenomena also point out towards divisibility of the atom. For example, why do different bodies become charged on rubbing? Why do gases conduct electricity at low pressure? Why does the electric current cause chemical change? How does the current flow through a metallic conductor? The first indication about the divisibility of atom and charged particles as constituents of atom came from the study of static electricity, the conditions and the properties of charge which enable conduction of charge. Let us perform an activity to know about the charged particles of a matter. Comb, tray hair and bring the comb near the small pieces of paper. Take a silk cloth and wrap the glass rod with it. Bring the glass rod close to an inflated balloon. What do you observe? Does the comb attract small pieces of paper? What happens on rubbing the glass rod with a silk cloth and bring it close to the inflated balloon? The observations are: the comb will attract the small bits of paper and the glass rod will attract the balloon. On the basis of these observations, we can say that when two uncharged bodies are rubbed together, they get electrically charged. From that, we conclude charging of bodies on rubbing shows that there must be transfer of some particles from one body to another, which proves that these particles are obviously not atoms but some smaller charged particles. This activity proves that on rubbing, the body gets charged. The charged body attracts the uncharged body by creating opposite charge in it. Now the question arises in our mind: what is the charge and where does it come from? This could only happen if the atom is divisible and consists of charged particles. It was found that The charge was due to electrons. When these electrons move out from any body, they create positive charge on that body. The electrons create negative charge on the body on which they arrive. Discovery of electron and cathode rays. The electron was discovered by Sir J.J. Thomson in the year 1897 during a detailed study of cathode rays in his discharge tube experiment. Let us learn what is discharge tube. Discharge tube is a cylindrical glass tube about 60 cm long in which electric current can pass through gases under very low pressure. William Crookes, a British scientist, in 1879 discovered that gases are ordinarily poor conductor of electricity even when electric potential of about 10,000 volts was applied. But gases start conducting electricity when the pressure inside the discharge tube reduces gradually. A discharge tube has following components: the glass tube, which has both the ends shielded, two circular metal plates as electrodes. The positively charged electrode is known as anode and the negatively charged electrode is known as cathode. Side tube fitted with stopcock, which can be connected to the vacuum pump to remove the air and to develop low pressure. A source of high voltage connected to the both electrodes. The common examples of discharge tubes are X-ray tube, CFL, picture tube of the TV and electric tube lights. Experiment conducted by J.J. Thomson. J.J. Thomson connected the electrodes of discharge tube to a source of high voltage. An induction coil or any other source of high voltage was used for this purpose. The discharge tube was attached to vacuum pump through which air pressure was reduced. Therefore, the tube was filled with air or some other gas and 10,000 volts potential was applied on it, taking normal pressure. Being poor conductor of electricity, no current flowed through air, even when a high voltage was applied through it. Air pressure was reduced to 1 mm of Hg mercury by using a vacuum pump, due to which the electricity started flowing. As a result, the tube started glowing. On further reduction of pressure up to 0.001 mm of mercury, the wall opposite to the cathode started glowing with a faint greenish light called fluorescence, which occurs due to collision of invisible rays on the wall of the tube. These rays are called cathode rays. They are negatively charged particles. Experiment conducted by Goldstein. Eugen Goldstein used a discharge tube having perforated cathode to produce anode rays. When the tube was connected to about 10,000 voltage source, very dim luminous rays were seen extending from the holes of the perforated cathode. Perforated means the holes. These rays were moving exactly opposite to the cathode rays. Goldstein concluded that these rays were composed of positive charges. So, he named these rays as Canals Kalina or channel rays or canal rays, as they passed through the holes or channels present in the cathode. But the actual nature of the particles of canal rays was found in 1907 when these rays were treated under magnetic field. The experiment revealed that all the particles of anode rays do not have the same mass. The lightest one was formed when hydrogen gas was used in the tube. The anode rays obtained from hydrogen gas are composed of same type of positive particles. These positive particles are named as protons. The mass of the proton was approximately 2000 times as that of the electron. In general, an electron is represented as E and proton as P. The mass of a proton is taken as 1 unit and its charge as +1. The mass of an electron is considered to be negligible and its charge is -1. So, an atom was composed of proton and electrons mutually balancing their charges. It also appeared that the protons were in the interior of the atom, whereas electrons could easily be peeled off but not protons.